This worksheet really is a pretty deep, intense kind of a worksheet. We're really trying to look at how portfolios are created so that we can choose the optimal portfolios within the efficient set of the efficient frontier, if you will, of our universal set of securities. So in this case, we have three assets, A, B, and C. We know what the returns of the assets are from our calculations. We also know what the covariance is of our assets. And again, we can input all of those in these yellow boxes. That gets all that data. But then we have to ask ourselves some questions about the portfolios. What if we wanted a portfolio that had a return of 0.5%? In this multi-stock state, multi-asset portfolio, we are in not a two-dimensional state now. Now we've gone into a three-dimensional state. So we would like to find different portfolios that could create the same outcomes, if you will. And the first thing we want to do is calculate what's referred to as Iso return formula. So let's say we want a return that's going to get a 0.5% return. And this 0.5% return from our data is a monthly return. We then input from that different weights that we may want to look at. So for asset A here, portfolio 1, we want a 90% return. In portfolio 2, this says 150. Well, let's make this a 25% return, right? And in portfolio 3, let's make it a short sale. So let's make it a negative 25% return. Right? So we can put different weights for A. And what this does is it calculates the weights of the portfolios that will create a rate of return of 0.5%. All of these portfolios, 1, 2, and 3, they all would give me a rate of return of 0.5%. So this is, in the context of the class that we've been discussing, this is a plane of returns. Everything on that plane has the exact same rate of return. Which portfolio would you want from that particular plane? Not all of them are appropriate. We want to match the maximum rate of return with the minimum amount of risk. So let's say we're willing to take risk. Let's make it 50%. That's what we want our variance to be. So now we can then calculate and say, well, wait a minute, what portfolios are going to create a variance of 50%? And we can plug in the same information here as we did up above, right? And we can change. And this will tell us, in this case, we're creating iso variance lines. In the context of the course, these are the ellipses. They are a oval-shaped set of portfolios, and everything on that portfolio has the exact same risk. So these three portfolios would all create a 50% desired variance. In addition, because this is an ellipse, there are actually two sets of portfolios. It's created ultimately through our formula in the class through a quadratic equation. So it's a plus and minus kind of calculation, if you will. So there's also three other portfolios, as you see, that also have a variance of 50% and also have weights of 90, 25, and negative 25 themselves. So what we've created now is a set of portfolios that will give us a 0.5% rate of return. We've also looked at identically weighted portfolios, but in this case, we're looking at the variance, and the variance of these portfolios would be 50%. So ultimately, what would be the returns, if you will, of the portfolios of these risk portfolios utilizing the three portfolios up above here that we've been talking about? As you remember from class, we create a quadratic equation to solve for these answers. That's why we end up with the two sets of portfolios. So portfolio 1, right, with 90% in A, 21% B, and 11%, that would give us a rate of return of roughly 0.098%. That portfolio also then, the returns for these iso variance portfolios, in this portfolio, that would be 1.185%. Portfolio 2 also has what? It has two different sets, if you will, of weights that provide different returns for those iso variance portfolios. Again, this is an exercise in trying to visualize and understand how the efficient set evolves as we go from a two-asset portfolio to a multi-asset portfolio.